Okay, so welcome again to the second functional skills maths recording. So what we're going to work through today is estimations. So the presentation I'm going to sort of go through sort of fairly briskly. So I encourage you to pause the presentation whenever you're given the opportunity to complete your calculations. At the end. At the end, we're going to set some knowledge check questions, which I want you all to complete and send in. So by the end of the session, you should be able to understand this concept of place value. You should be able to compare numbers and use the inequality sign, so things like greater than, less than, that kind of thing. We hope you'll be able to use approximations in providing estimates of quite complex calculations, and we're going to kind of assess you ultimately on your ability to use sort of place value in large numbers, and we'll see this through your completion of the knowledge check questions, and also a bit of your work around this topic that comes in. At the end of it, I'll go through those knowledge check questions. So first of all, we're going to start with this concept of how we read and write numbers, and some of this should probably something you haven't sort of thought about. I know I sort of haven't given it a great deal of sort of thought, but I guess one thing to consider is what we see as the difference between a number and a digit, and so that's a strange sort of question. So to break it down simply, our digits are our numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So each one of those is a digit. And then we make up numbers using those digits. So numbers are made up by combinations of those digits or individual digits when you've only got single digit numbers. So the place value of each digit in a number depends on its position or place within that number. So if you look at the picture above, the line above, we've got this number 697. So each of those digits has a different place number or place value, within that number. So we'll start breaking that down a little bit. So here we've got the number 1 million. So if you look at that number 1 million, we break it down into units at the very bottom. So something like 1, 2, 3, they're all units. We then have tens. So when you get above 10, each number will have a 10 value. We go to hundreds, thousands, tens of thousands, hundreds of thousands, and then finally millions. So the million has 6 zeros. We can see this 1, 2, 3, 4, 5, 6 zeros. We have this number 1 right at the very end. So the place value of that digit is 1 million. So I've just copied that table out just because I think it's quite useful for this slide. So the question is, what is the value of the 3 in each of these numbers? So I just want you to pause the presentation and just try and consider what is the value of the 3 in each of these numbers. So what is it in that first number, 2,000,003? What is it in that second number, 25,639? What is it in the third, C, D, and E? So just pause the presentation and have a go at that. So what you should see is the first one is we've got 2,000,003. So the 3 in that is worth 3 units. So if you just watch that bottom, so it's 3 units. Let's see what the next one is. it's 3/10. So the 3 in that 25,639 is 30. So the value is 3/10. You can probably guess where this is going next. So 888,324. So the place value of the 3 is 100. So let's see if that's right. So 3 hundreds, and then a little skip. So we've got 3 hundreds of thousands in that one. And then we're going to nip back. So 35,802. So you can see we're missing one. So here we are, 3 tens of thousands. So that's what we mean by the concept of a place value. So we also consider this idea that numbers have different amounts of digits, or the digits mean different amounts in them. So numbers can be referred to as 1-digit numbers, 2-digit numbers, 3-digit numbers, etc., etc. So here we've got a couple of examples. So what we can see is 6. Think about how many digits that number is. It's 1. So 6 is a 1-digit number. So you only use those digits, those units on the left-hand side of that previous table. So 37 is a 2-digit number. 837, a 3-digit number. 2,879 is a 4-digit number, and so on. So the question you're posed here is using these numbers, 2, 3, 7, and 9. I want you to form a 4-digit number, and I want you to think of what is the largest 4-digit number you can make. So I want you to pause the presentation now. So if you've calculated a 4-digit number, we'll have obviously used all of those available numbers, and you'd have thought, well, actually, where does the biggest number go? And hopefully you've popped it on the left-hand side in the thousands column. So we've got 9,732. So now we're moving on to these concepts of using figures to describe numbers as being more or less than another number. So we determine whether a number is greater or whether it is less, and we can use symbols as a sort of shorthand. This is quite useful in certainly in fitness industry, where we look at we certainly do things like categorizing people in certain body mass index levels, certain things like body fat percentage. We look at things like blood pressure, and we look at people being above a certain level, and there might be some danger in them having particularly high blood pressure, and we're looking to sort of get it below a certain level. So we quite often use these shorthands just when we're looking at various fitness testing figures. So they're quite useful things to get in the habit of using. So here we've got an example. 100,000 is greater than 99,999. So if you look at the figure, the symbol that's been used, we've got this sort of kind of a V shape. I don't know what its real name is actually, but that's what we have. And what you see is the larger number, the greater number, is on the side with the widest sort of opening, if you like. So the largest number, 100,000, is on the side of that largest opening. We're comparing it to 99,999, which is on the side of the smallest part of that symbol. So that's a nice way of looking at it. So here we've got another number, so 999,999, and we can see that that is actually smaller than that number 1 million. And you can see the figure in this case is reversed. So the smaller side of that symbol is on the side of this, remains on the side of that smaller number, and the larger side of that symbol remains on the larger side of that number. So that's expressing that 999,999 is smaller, less than 1 million. So now I'm going to get you to pause the presentation and complete these questions. Just pause it. All you're writing is which correct symbol goes in the place of each of these three. So just take a scrap piece of paper, write it down. But to do that, I need you to pause the presentation now. So hopefully you've managed to pause and had a good go at those. So remember, we're just inserting the greater than or lesser than or less than symbol. And we were trying to remember that generally the larger side goes on the side of the larger number. So bearing that in mind, you can see that A is this side. So the larger side of that symbol is on the side of that larger number, 185,789. So you should look to the next one and hopefully you've got what we have there. So on the side of the 99,000, and then here nicely fitted in on the larger side on that 87,654. So hopefully that's making sense. We're now now pressing on to this section of estimating calculations. So here we're going to consider maybe why we need to estimate calculations. So what it's useful for often is we can consider in everyday life it's useful, particularly if we're shopping. It's useful to be able to quickly estimate amounts of money that we're dealing with, to make sure you've got enough money to pay with. It's also useful certainly in the fitness world, when you're particularly under pressure, when you're dealing with things like, again, fitness test results, and you're sometimes doing quite detailed calculations. It's useful to just in your mind make a quick sort of snap estimation to make sure that the calculation you're making is on the right lines. So you might kind of give people quick verbal feedback in the immediately after the test, and then say, okay, well, what I'm going to do, I'm going to go away and calculate this properly. So you want to make sure that first verbal feedback is near, and also that the second calculation you make, when you really have time to do it, is in the right ballpark. You haven't sort of messed up your calculation. So if you've completed a good estimation, you've kind of backed yourself up. So imagine you're in a shop, you want to buy several items, you have £10 to spend. So I want you to quickly estimate the total cost to make sure you've got enough money. So here we've got 1, 2, 3, 4, 5 items. Now, have I got enough money to spend? So quickly, magazine, £1.95, loaf of bread, 99p, chocolate, 85p, bananas, £2.10, and washing powder, £5.19. So just give yourself 30 seconds, figure it out. You've got to estimate it. Go. Okay, your time's up. So, can we pay? Well, let's have a look. Do you have enough? Well, we have a way of estimating it. What's quite a useful method is to just try and round things up to the nearest pound. And certainly in shops, this is usually quite easy to do, because often prices are quite close to their nearest kind of place value, aren't they? So you often see things rounded up to £1, or rounded up to near £2 or £3, or near £10. So here we've got some items that are getting towards that sort of rounding up. So here we've got, we're going to round everything up to the nearest pound. So the magazine, we've rounded up to 2. The loaf of bread, we've rounded up to £1. The chocolate, 85p, up to £1. The bananas, we've actually rounded down to £2. Then our washing powder, we've actually rounded it down to £2. So again, this is just a quick sort of snapshot way of estimating items. So the rounded up values go up to £11, so it feels unlikely that we're going to have enough to buy everything. So we can do the calculation anyway, but if you imagine if you're at in a queue and you're sort of having a little panic that you might not have enough money, sometimes you don't have a calculator to hand or want to go through the whole process. So it's useful to just sort of in your head go through that rounding process. So even if we really need to know that exact answer, the shopkeeper's not going to accept your rounded up version. The estimating an answer can also give you confidence that your calculation is correct. So this is valuable, certainly within fitness testing. You can do quite detailed assessments of people's fitness test results. Certainly in things like nutrition, it's really good where you're estimating things like people's basal metabolic rates, and they're quite long, complex calculations. And so if you perform an estimation, it can kind of give you a greater amount of belief and confidence that the actual figure you're presenting is correct. So what I want you to do now, we'll give the example first, then you can have a crack at a couple. So here we've got an example, 312 minus 97 divided by 9.8. So that immediately looks beyond my fuzzy brain. So how can we make that a little bit easier? Just looking at that, what would you do? Well, what we can start to do is round each number. So we can do a rough calculation to estimate the total. So how would you do this? Well, I'm just looking at that and thinking, actually, what I could do is take the 312 down to 300. I could take the 97 up to 100. And I can take the 9.8 up to 10. So broad rounding, giving me a sort of very rough idea. Now looking at that, 300 minus 100 doesn't look quite so scary, does it now? And then so you're going to be left with 200, and then 200 divided by 10. Quite an easy calculation, isn't it? So this gives us 20. So that's quite a nice sort of technique to consider. So here we end up with 312 minus 97 over 9.8. We estimate at 20. So there's another symbol for us to use. This sort of slightly squiggly equal sign shows that it's an estimated at 20. So the approximately equal to sign is used to show that values have been rounded. So to kind of interpret that result with a degree of caution and sort of show that it's being used as a suggestion and an estimation. So the right answer, if you did get your calculator out, would have been 21.84, which is pretty close. So, in the broad scheme of things, it gives someone an indication of what that figure was. And it shows that when you completed your final full calculation, you knew you were in that right ballpark. So now we're going to do a bit of estimating of calculations. So what are you going to do if you're faced with that question there? 203 times 42. Well, hopefully you've got an idea about where you're going to go with it, but you've whipped your calculator out and you've gone, okay, well, the answer's 966. So I want you to think, is that the right answer? And can you explain why? So what I want you to do is in a second, I'm going to ask you to pause the presentation and I want you to estimate the answer to that calculation. And I want you to consider, is that question right? If not, why not? So pause the presentation, figure that out. So hopefully you've had a little go at estimating and actually looking at that calculation, it doesn't look quite right, does it? 203 times 42 seems a little bit large because 4 lots of 203 is going to be over 800. So let's just do the process. So we're going to estimate the answer by rounding. So what we've got here is 203 times 42. So we're going to round that down in the case of the 200 and also down in the case of the 40. So we go 203 times 42 becomes rounded, and we go to 200 times 40. So let's see what that looks like. 200 times 40 is 8,000. Seems a lot. So we would expect our estimate of 8,000 to be close to the answer on the calculator, but it's not. So it means that that initial 966 is not the right answer. We must have made a typo somewhere. So the fact that we've taken the time to just quickly estimate gives us that confidence, or we kind of know immediately that our calculator value is wrong. So the more we get in the habit of creating these quick mental estimations, the greater confidence we have in our final calculation. So if all we ever do is create these long, complex calculations, we're calculating people's sort of body fat percentages via computer, via calculators. If we don't know where that figure's come from, we could be predicting people some quite wild stuff. So the actual answer was 8,526. So now we're going to do a slightly extended calculation. I want you to work through this. So Oliver is training to do a 6-kilometer open water swim. He swims around a lake, each lap of which is 987.5 meters. He goes at a steady speed. It takes him 19 minutes and 34 seconds to swim one lap. So I want you to pause the presentation and I want you to estimate and use the right symbol how long it takes Oliver to swim 6K. So pause the presentation now. So hopefully you've had time to calculate that calculation. So if we look at the things that we could potentially round, well, let's see what we can see. Okay, so luckily each lap is getting near a kilometer, isn't it? So we can kind of look at this and say, okay, this is where my writing goes horribly wrong. 1 kilometer. Oh dear. So each lap is around a kilometer, isn't it? So how long does it take him to do each lap? Well, we can see he's as near as possible to around 20 minutes. Getting better, aren't I? No, I'm not. There we go. So each one's around 20 minutes. So here's our full calculations. So 987 meters, or 987.5, is close to a kilometer. One lap is about a kilometer. And 19 minutes and 34 seconds is approximated to 20 minutes. So it takes Oliver approximately 20 minutes to swim one lap, which means it takes him approximately 20 minutes to swim a kilometer. So if we take that 20 minutes, times it by the 6 kilometers, then we've got 120 minutes. So good luck, Ollie. You've got to swim for 2 hours. So that's a quite an impressive feat on his part. So from taking what initially looked a very complex calculation, you should hopefully see that by just completing these basic estimations, we can really start to sort of hone in on what that requirement is. And again, this is valuable certainly if we're looking at clients that are training for things like endurance runs, and we're sort of trying to build out sort of routes for them to follow, sort of training volume. Certainly we're looking sort of say, okay, well, go out and do 1K at this pace, 2K at this pace, etc., etc. It's useful to use these kind of estimations just to sort of think, actually, what am I asking my client to do? Because I think a lot of the time we really overestimate what people are actually doing. It's and so it's useful to complete these estimated calculations, particularly when we're looking at training programs. So there we are. So by the end of the session, we are asking you to be able to understand place value. So we quickly reviewed that at the start. We looked at that picture of a 1 million, and we looked at the place value of each digit within that number. We looked at the concept of units. We looked at tens, hundreds, thousands, tens of thousands, hundreds, thousands, millions. So we used numbers and inequality signs. So we looked at the use of the greater than or less than symbols. And we also used the symbol for approximation. We used approximations to calculate some slightly more sort of complex, well, some simple calculations, the sort of thing you might do in a shop or while dealing with quite sort of simple fitness tests. And then we used a slightly more complex one to look at sort of training load in a sort of a real life situation. So all you've got left to do now is complete your knowledge check questions. So your knowledge check questions are here. I would suggest you either pause the presentation or use the sheets that you have access to. Complete them either on the sheet that you've been given and print and send, or complete on a fresh sheet of paper and prepare to send as well. So here they are. There's just two groups. So roughly, do my estimation, 4, 5, 6, 10 questions. So in part 1, you're using the greater than or less than symbol. And then in part 2, I want you to estimate those calculations. What I'd like to see in part 2 is your workings. So what would be suspicious is if all I saw was the perfect answer for each one. So I need to see that you've gone through in part 2 the process of using those estimations that we've just discussed. So pause the presentation if you're keeping it on screen, or close now and go and access the sheets that you will also have been given. So thanks a lot and good luck with your knowledge questions.